Thank you, Mr. Chairman. Dr. Green, traditionally planetary exploration was a public sector endeavor that taxpayers took care of. Today, the U.S. private sector companies are beginning to invest and develop planetary exploration programs. What is NASA doing to facilitate and encourage private sector investment and participation in planetary exploration?
I believe there's a whole range of things that we've been involved in. If you take an example of the concept of going to asteroids and being able to extract certain metals and other compounds of interest, the first thing that they're going to need to know is where are they? What is their characteristics? How to get to them? And indeed, we are doing an extensive finding project where we'll find our small bodies, we'll catalog and characterize them, and all that information will be critical. And we've discussed that openly in many different meetings working with that sector. Another sector is a series of commercial opportunities going to the moon. Now, this could be a really important element for scientists to be able to work with the commercial entities and be able to obtain rides to be able to bring back material or examine certain regions on the moon that are extremely important. The moon is still quite valuable in terms of being able to provide us an enormous amount of science that can be done. It's been a witness plate of over 4 billion years of impacts, can tell us a lot about what's happened to our environment and what's happened to the Earth. So those partnerships are beginning. There are some that are done through a Space Act agreement, and others are done through collaborations and discussions at a variety of venues.
Thank you very much. That's a good answer. Given the important role of robotic planetary missions in advancing human exploration capabilities, how can the current and future planetary missions be integrated in the human exploration roadmap, which we've asked NASA to produce?
Well, of course, from my perspective, planetary scientists are really the guides. They're really the ones that go out first. Human exploration is not Star Trek. It's not go where no human has gone before. And our program in NASA is really all about sending humans to locations beyond low Earth orbit, out into the solar system, be able to live, work, but also return. And all those require not only where you're going, but the characteristics of how to get there, what are the kind of science and other activities one can do on station, and then, of course, the challenges of entry, descent, and landing for any of the bodies they choose to go to. We pioneer a lot of that, in terms of being able to look at those environments, collect that information, but also pioneer some of the initial technologies that allow us to get our rovers and other machinery at various locations, whether it's the moon or Mars.
Okay. Can you describe the infrastructure that missions will be putting in place around Mars and Europa to support future missions? For example, will NASA be able to use the Europa clipper to support future Europa missions, namely the lander?
Yeah, actually, as Lindy mentioned earlier, in planetary science, we really have a very important paradigm that we follow. It's flyby, orbit, land, rove, but also return those samples. And indeed, the Europa clipper gives us that opportunity to do a detailed examination of Europa that provides high-resolution imaging that gets us right to where we want to go, that makes the next mission, which would be notionally a lander, to be able to land safely and perform the science that we want it to do. So indeed, each of these missions are very much related and depend on the success of the previous mission.
Thank you very much. I yield back, Mr. Chairman.